Hello everyone. Here today we're going to focus on what's involved in the setting out of a quarter turn of tapered steps, or winders as it's sometimes referred to. We will be basing our setting out on an 8x4 sheet of plywood or similar material. So the video will start off by drawing a plan view of that quarter turn of tapered threads. Uh, and on which we'll develop the true shape of those threads. And after that, then we will be focusing on developing the true shape of the string on both walls. Then after that, then following on from that, we will also be developing the housings on the Newel post. So that'll be the main thrust. So here we have an 8x4 sheet, and we're starting from the corner of the sheet with a 45-degree line. So basically, if you measure up 4 foot along the length of that 8x4 setting out sheet, which is shown here in grey, and draw that diagonal line, then basically you'll have your 45-degree line. And then after that, then you'll be drawn in the plan view of the wall string, as it were, both wall strings actually. So basically, you formed a square with a diagonal line to start with. And then on that diagonal line, you're going to have to position your newel. So depending on the width of your stairs, of course, it'll move further in or further back on that 45-degree line. So whatever happens to be the width of your straight flight coming down onto the winders, that's where you'll position your string and newel, but it has to stay on that 45-degree line. So that's basically the next step you'll be doing here. Now that we have the newel post in position with the newel string, we need to find the or determine the first and fifth rise line, which is the horizontal and vertical line that's going to be shown here. And the distance from this line to the newel post will determine how narrow the tapered steps will be before they come to that newel. And obviously you don't want them too narrow, and you know, there will be local regulations depending on what part of the world you might be building the stairs in. Sometimes it could be, you know, the regulation might state that it should be no narrower than 75 mil. Other countries might state that it can be as narrow as 50 mil. So you need to check out local regulations in relation to that. And you may have to adjust these vertical and horizontal lines that have just been animated here. So that's basically the next step. So once we're satisfied with the position of our first rise line at the floor level and our fifth rise, our next objective now will be to put in the lines that represents the second and fourth rise lines. The first step to getting these rise lines will be to strike an arc using a trammel as animated here. As you can see, the center point for this arc was where the first and fifth rise lines intersect, and try and have the radius of the arc maybe 3/4 the way across, so it'll be a bit more accurate later on when we're dividing. Next, where the arc intersects with the first and third rise line, we will draw a straight line. And once we find that straight line, as you'll see animated here, we'll extend a line from the center point of that arc through the midpoint of that line shown in a red dot here to extend out to hit the string. And we'll repeat that process then between the third and fifth riser to give us the fourth rise line. So here we will take the necessary steps to find the center for the bullnose on the first riser. And we'll do this by taking the distance from the face of the newel to the first rise line at floor level there, which is the line is indicated in grey with 2 strokes across it. And then we'll go the same distance horizontally to where I have a red dot there. And that'll be the radius point or center point for that radius for the bullnose. Then after that, then we were focusing on the second riser, which has a slight curve in it. And I've got that slight curve bent outward slightly as well by maybe 5 degrees, as you can see here, to make the step just that little bit wider where you come around the newel post sharply as you're coming down the stairs. You'll start the process there then by drawing that the last piece of animation will be a line drawn across there on the longer, wider blade, and that'll start the process to find the center for that curve on the second thread. Now we will complete the process to find the center for this curve on the second riser by keeping the frame and square illustrated here on our rise line, and but keep that frame and square the same distance that the line from the newel to that rise line was. Now keeping that same distance along that rise line, as you can see here by the double strokes on each line, just to indicate that they're both the same length, those 2 grey lines. And then once we draw those lines, we extend those 2 lines until they intersect with each other, and that will be the center for that curve. Next, we have the junction established to give us the center for this arc, as you can see here, and it's animated here now in green coming out from the newel post. Okay. Animated here next is the addition of the thread lines in white. So that'd be that would be 25mm past the face of the riser. So that's your nosing line, as it were. So coming into view here is the true shape of the first thread, and I want you to notice that it is actually going into the newel by a half an inch, and it's also going into the string drawn in blue over on the left there by also half an inch. So housings obviously will have to be developed later on to accommodate how much the thread will have to go into the newel and string. So this is the true shape of the second tapered thread. Here we have the third tapered thread. Notice that the back line is in line with the rise line, whether the front line of it is right out to the nosing line. And it's of course it's hatched here in oak. And finally, here's our fourth oak tapered thread. Next, we're going to develop the true shape of the wall string, and we'll start this by projecting the thread, riser and newel lines upwards from the plan view that we've already drawn earlier. So let's get started by moving up along this setting out sheet here. Here I've drawn the second rise level in red, as you can see there, and we will have a what's called a story rod, which is basically a lat with all the rises for this particular stairs marked on it. And off that we will transfer lines that would mark our tread lines. Notice I've extended 3 black lines here from where the rise line meets the string, and our rises then are measured along those lines to complete our steps. The story rod is used once again here to mark the 4th tapered thread housing, and we'll also complete the 4th riser housing as well. The 5th thread is now completed here to include its riser as animated. It should be noted that the thread and riser housings shown here will also have to be expanded to accommodate the shape of the riser and thread wedges also, which will also be housed in at the same depth, which is a half an inch. The outline of the threads and risers that we've now drawn is actually going to be of benefit, because we can now use that to draw in our string lines, as you will see animated here now. Notice it was the first line drawn was the main stair pitch line drawn from the bottom corner of the 5th riser. And once we had that line drawn, all we had to do then is to get the second line was offset or measure the width of that string. And you can see then 3 little pink double-ended arrows there, basically our upstand margin distance, shall we say. And we use that then to complete the raked portion of the, or cranked portion of this, of that wall string. Here we're going to start the process of putting a radius or easing at this point of the string. So we start by using an offcut of a piece of plywood to start the process of finding the center for that easing of radius as animated here. So we'll continue the process with the same piece of plywood to mark the second line, and we'll be using that junction and that's created between those 2 lines to find the center for this radius for this easing. Presenting here then is the 2 junctions that's required for this line that we're drawn. You have the junction from the raked string lines, and you have the junction, the 2 grey lines basically, and where they intersect, that broken pink line that's going out of picture, where the 2 intersect, that will be the center for that radius. So you can use a trammel or whatever then to strike those radiuses. The top of the top easing and lower easing on that string is shown there. Okay, so now we're going to focus on the shorter wall string. This will be a similar procedure as with the previous wall string. So again, we'll be extending the rise lines shown in black here from the plan lines of those same rise lines where they meet the string, and we will use the rise distances as we did off the story rod in the previous string we developed, as we animate here now. So using a trammel, we can quickly add in an easing to this shorter string as animated here now. And here we have the through shape of this wall string now shaded in a green here. Our next focus now will be on the newel or stub newel. So we need to develop um, where the positions of the housings are on that newel, and we have to make sure it stays relative to where the newel string makes contact as well. So let's get into that now. So here we're going to project the lines that we drawn earlier from our stub newel, and we'll move up along the setting out sheet now to produce the view against the string, um, to start the process of marking the housings on that newel post. And here coming into shot now is the newel post itself, placed projecting the required amount above the string before we start marking the housings. So here I've shaded in the newel string in blue so you can see how much the newel post itself is protruding above that newel string. Here we're using a story rod, which is basically a 2x1 lat, which the rise is marked on it for each rise for each step, and that's been transferred onto the newel post here right now. Animated here is the transfer of lines from the setting out sheet where the newel string meets the newel post, whilst keeping the rise line in line with the tread line on that setting out sheet. That's very important. Just want to make a few important points here. Um, the newel string there shaded in blue. Uh, you can see the thread and riser housings there. For instance, you're going to get your shoulder lines for your marks and tenon where it goes into the newel, and the distance from that shoulder line to the face of the riser there, the riser housing on your newel string, is a distance you'll need to know when you're setting out that. So there's a little bit of information there just to be aware of. I also want to bring your attention to the newel string easing piece that's coming into view here. That's there to accommodate the uh, riser housing that's going to extend down beyond the um, initial string line. Coming into view here is the face of the newel that will have the first housing for the tread and riser taken out of it. Uh, so that's been animated here now, and you can see those lines are taken off the curved riser line that's coming in there to the plan view of that newel, and it will have been shown in red on the side of that same newel. By the way, there's usually an inch and a half or 2 inches of extra newel post going below the floor level, and you can see that floor level marked with a broken purple line there on this view here. Anyway, here is lines off the plan view for tread, or sorry, riser and nose and lines. relative to three different levels, we'll say, of thread, as you'll see animated here now. This is the second face of the stub newel moving clockwise around the plan view of the newel. And you can see here we're marking in the waist with X's, and of course those housings marked in red will be have to be mortised out and drilled out a half-inch deep later on. So this is the third face of the newel face moving around clockwise. So this is on the inside, as it were, of the newel post, and you can see the housing where it's taken off here from the plan view of that step. And here we're going to add in the housing for the riser that's coming into the newel post on this face. And you'll notice that the shoulder on the left of screen there, it's not a square down shoulder. That shoulder is sloping at 45 degrees, as you'll see will need to be the case if you look closely at the plan view of where that riser comes into the newel post. The main point of this illustration is to show you how the lines marked earlier on this first face of the string shown on the left, which are at an angle, are transferred onto the face of the string where the newel string is coming into contact, and you can see there clearly where the mortise starts and finishes because of those lines that are now have established those points. So that's the main point on this particular illustration here. Shown here is all four faces with their housings marked out, including the one with the mortise marked on it. I just want to have a quick word about the first two risers with regards to getting the curve on both of them. The first riser is a sharper, tighter curve, so it will require a built-up farmer block, almost the height of the riser, and you'll get the shape of that off this setting out that we've done here. And you can see one end of that farmer, it hooks into the riser then, and that's the end you'll put in first, and you'll glue it and you'll screw it, and then you'll roll the veneered, the section that has been left very thin or veneered, until you get to the other end, and there then you'll be stretching the veneer over the farmer block by driving in a wedge in that gap that I've shown there, and then you're going to screw it in on that end as well into the riser, into the thicker section of the riser. So that's just to give you an idea of where you're heading there with that first curve. This second curve on the second riser coming up from the lower floor level, um, this this is an easier process to deal with because it's a much smaller, it's a larger radius curve, so it's easier to deal with. So merely putting some saw cuts at the back, or kerfs as you want to call them, will be enough just to weaken the riser enough so as you can bend it, and once you fix that into the back of the thread, that'll hold the true curve at that point for you. Okay. Coming up here next is a quick animation I put together just to give you an idea of the process or procedure you'll have to undertake when you are assembling this particular set of tapered steps for this quarter turn. So here you'll see the first two straight threads, as it were, sliding into its housing, and as each thread is slid in, the riser, which you can see from this view, is slid up at the back and wedges are driven in, etc. And you progress on then downwards, and you'll see that you'll have to approach from a different direction then for the last two tapered threads. Just want to make some extra points before we close off. Um, Sometimes you're in a situation where the pitch of the main flight of stairs going up to the next floor level is a bit on the steep side, and you'd like to pull all the risers forward towards the shorter wall string, shall we say. And I've animated that here, that it is possible, and you could do it, and you might want to consider doing it. Uh, and it'd mean that instead of that fourth tapered thread being housed into the Newel string, it would instead then be housed into the Newel post itself and the riser, which means there might probably or would be no need for an easing piece, or should be no need for an easing piece then at the bottom of that string, which is another advantage, and it might get you to the required pitch that you need to get to at or below to keep within building regulations. And if that is not enough then to get the pitch to where you need to be, then the next option would be to move the or reduce the distance between the Newel post and the shorter wall string, and maybe reduce the width of the stairs itself. Okay, everyone, that's it. Hopefully that gave you a good insight into what's involved with setting out a quarter um, set of tapered steps or winders for stairs. All right, all the best.